If you're a developer, a cloud engineer, or in DevOps, you probably think of DNS as the internet's simple phone book. But what if I told you it's one of your most powerful tools for controlling performance, ensuring uptime, and even managing costs? Welcome to another interesting video from Mech Cloud Academy. In this video, we'll show you how to leverage DNS far beyond basic A records. We will dissect critical record types and explore the sophisticated routing policies that modern infrastructure depends on, like weighted routing for A/B testing, latency routing for a global user base, and failover routing for bulletproof disaster recovery. By the end of this session, you won't just understand DNS, you'll know how to wield it as a strategic tool. Let's dive in. Here's how we'll break it down. We'll start with the fundamentals, asking, why do we need a DNS server? From there, we'll explore the essential building blocks, the different DNS record types. Finally, we'll dive into the powerful part, the various routing strategies you can use to control your traffic. It's important to note that this video will focus on the universal concepts and principles behind these strategies. These are the foundational ideas that power services like AWS Route 53, Azure DNS, and Google Cloud DNS. We'll cover the specific implementations and how-to for those cloud platforms in dedicated deep dive videos in the future. So with that said, let's get started on the core concepts. Imagine trying to call a friend without a phone book. You'd need to remember a long, complex sequence of numbers for every single person you wanted to reach. Now, apply that to the internet. Websites are identified by numerical IP addresses, like 192.168.1.2, which are incredibly difficult for humans to memorize. Without a DNS server, every time you wanted to visit a website, you'd have to type in its exact IP address. Just like a phone book translates names into phone numbers, a DNS server translates human-readable domain names, like google.com, into those machine-friendly IP addresses. This seamless translation is why DNS is absolutely crucial for navigating the web, making it user-friendly and accessible. Let's elaborate on two fundamental DNS record types, the A record and the CNAME E record. An A record, short for address record, is perhaps the most common and crucial type. It directly links a human-readable domain name like example.com to its corresponding IPv4 address, such as 192.0.2.1. This is how your browser knows which specific server to connect to when you type a website address. Now, consider the CNAME record, or canonical name record. Unlike an A record that points to a specific IP address, a CNAME creates an alias, pointing one domain name to another domain name. This is incredibly powerful for integrating third-party services with professional branding. For instance, you can create a CNAME to point your custom subdomain, support.example.com, to the generic URL from your SaaS help desk, like example.saas-provider.com. The real magic is that if the provider ever changes their server IPs, your alias automatically follows their DNS updates, requiring no changes on your end. This simple record provides a robust way to decouple your custom domain from external infrastructure, simplifying maintenance significantly. While we've touched upon these two key records, the world of DNS records is vast. In a future video, we'll delve deeper into the other important record types, exploring their specific functions and how they contribute to the internet's robust and efficient operation. This is where DNS evolves from being a simple phone book into a powerful toolkit for controlling your traffic. On screen, you can see the main strategies we're going to cover. Each one is a different tool for solving a specific problem. Whether you need to balance load, reduce latency for a global audience, or create a bulletproof disaster recovery plan, let's break them down one by one, starting with the foundation for them all: simple routing. Simple routing is the most straightforward DNS routing policy. It directs all incoming requests for a domain name to a single, specific resource. Think of it as a direct line. Every time someone types in your website address, they are sent to the exact same server. This method is ideal for websites or applications with a single server, or for services where all traffic is intended for a single endpoint, making it easy to set up and manage. Next up, we have round-robin routing, a simple but incredibly effective load balancing technique. Our diagram shows the classic setup. If you look at the DNS records, you'll see two A records for the same domain, example.com. Unlike weighted routing, these records are treated as complete equals. So, the DNS server acts like a dealer, distributing requests in a strict, cyclical order. The first request that comes in is routed to the server at 192.168.1.2. The second request goes to the next server in the list, 192.168.1.3. And the third request? It loops right back to the top of the list and goes to the first server again. This simple cycle ensures traffic is spread evenly across all your resources, which is a fantastic way to improve availability and prevent any single server from being overloaded. Next, we'll cover one of the most important strategies for any global business: geolocation routing. This isn't just about making your site faster, it's about control and compliance. Geolocation routing identifies where your users are coming from by country or continent and sends them to servers you have specifically designated for that region. This is critical for meeting data residency requirements, like GDPR. As our map illustrates, you can create a rule that routes all EU users exclusively to a server located within Europe. This ensures their data can be processed and stored within the required jurisdiction, helping you stay compliant. You can also use this to present different versions of your site, offering content or products specific to each region. Unlike other methods that just look for the fastest connection, geolocation allows you to enforce strict business and legal rules based on where your users are, making it an essential tool for managing a global footprint. Now let's look at a highly flexible strategy for fine-tuned traffic control: weighted routing. Our diagram shows exactly how this works. If you look at the DNS records, you'll see that in addition to the IP address, each record has been assigned a specific weight in its metadata. The first server at 192.168.1.2 has a weight of 95, while the second server at 192.168.1.3 has a much smaller weight of 5. This tells the DNS server to act like a smart traffic cop. It will send the vast majority of requests, 95% of them, to that first server. The remaining 5% of traffic is routed to the second server. This percentage-based distribution is incredibly powerful. You can use it to perform A/B testing by sending a small slice of users to a new feature. It's also perfect for canary releases, where you can cautiously roll out a new version of your application by slowly increasing its weight over time. Weighted routing gives you precise, granular control over exactly how much traffic each resource receives. Finally, let's cover a critical strategy for building resilient, bulletproof applications: failover routing. This policy is designed to keep your service online even if your primary server goes down. Our diagram illustrates this active/passive setup perfectly. You have a primary resource, the top server, and a secondary, backup resource. Under normal conditions, the system performs health checks on your primary server. As the diagram's top label says, as long as that server at 192.168.1.2 is healthy, all traffic is routed there. The backup server receives no traffic. But if that primary server fails a health check due to a crash or network issue, the magic happens. The policy automatically detects the failure and, as the second label shows, immediately reroutes all traffic to the secondary server at 192.168.1.3. This seamless switch ensures your application remains available to users, providing a robust disaster recovery solution and minimizing downtime. It's your safety net for unexpected outages. And there you have it, a deep dive into DNS routing strategies. We've seen how DNS goes from a simple phonebook to a powerful strategic tool for controlling traffic, ensuring reliability, and delivering a better user experience. Thank you so much for watching. If you found this video helpful, please give it a like and consider subscribing for more content on cloud and development topics. Let me know in the comments which routing strategy you find most useful in your own projects. Thanks again, and see you in the next one.